What we're talking about right now is the movement of an object or a person. Let's start by thinking about movement along a vertical line. Since this person is on a vertical line, there's only one direction they can move in, either to the right or to the left. How do we represent this person's location? When dealing with one-dimensional movement of a person, we represent this person's location in coordinates, right? We represented this person's position using coordinates. If you solved problem number 4 when you did your homework, you would know. To express the location of a person or object in coordinates or height, both represent position. When you represent height, you're looking up and down, and coordinates represent movement from side to side. So when this person moves to the right, you say that the position increases from the positional standpoint. And when they move to the left, you say that the position decreases, right? Are you all good up to this point, guys? Represents the location of an object in coordinates. If this object moves to the right, we say that its position has increased. Position is a coordinate value. When we think of coordinates, right is positive and left is negative. Guys, when moving to the right, the coordinates increase. Conversely, when moving to the left, the position decreases. The position increases and the position decreases. First of all, the term we learned is position, right, guys? Let's go over all the terms related to position today in this session. Position. We call position displacement, guys. When we talk about displacement, we use the position function, which we denote as saint. The S comes from displacement. When we use the position function, we use S. What do we call position again? If this is left and right, it means coordinates. And if it is up and down, it means height. So what is the location? It's coordinates or height. And when we create a function using position, that position function has t as the variable, right? When we create a function using position, that function is a function of t. T stands for time. We call position displacement. Position can be either coordinates or height. We're going to create a function with this. The function created at that time is a function of t, a function concerning t. We write the position function as saint. So, since this is a function of t, we write it like this, right? So, what we first talked about was whether an object moves to the right, right? When the position increases, then the change in position, delta s, is greater than 0. If, on the other hand, the object is moving to the left, the position value, which is expressed in coordinates, decreases. In that case, the change in position would be less than 0, right? Is this okay, guys? When we say it simply increases to the right, we can just say that the position increases. So the change in position is greater than 0, right? It's not wrong, but it doesn't sound very natural. The reason I brought this up is that there's something specific we can calculate with it. What can we find using the change in position, guys? That's speed. Now, speed. We can find speed using the change in position, right? So, speed is, when we think about this object in its simplest form, we are most curious about whether this object is moving to the right or to the left. The second thing we are curious about is how fast it is moving to the right. So, for example, if an object is moving to the right, from 1, you went to 10, how fast did you go? To answer that question, we need to know how long it took, right? So we define speed as the distance traveled divided by the time it took. And if we calculate this value, we can find out how fast the object was moving, right, guys? Is this okay? You need to understand the concept of speed accurately. So the second concept we learned last time was speed. We call speed velocity in English, guys. And we're going to use v for speed. So last time we wrote the speed function as vt, right? Is this correct, guys? Shall we talk about the definition of speed? What's the definition of speed? The amount of change in position, you divided it by delta t, right? In math, whenever you divide a change by another change, it's called a rate of change, right, guys? This is the rate of change of s, right? So the definition of speed, guys, is the rate of change of position. Should it come out right away? Speed is the rate of change of position, guys. There's a term for the rate of change of position with respect to t, but you don't really have to use it. The accurate definition is the rate of change of position with respect to t, but you can omit with respect to t. When defining speed, you should be able to mention this. It's the rate of change of position. The rate of change is the amount of change divided by the amount of change. Speed is the change in position divided by the change in t, so it's a rate of change. Therefore, it's the rate of change of s. But in math, there isn't just one type of rate of change. There are actually two, right? There's the average rate of change and the instantaneous rate of change. We have the slope between 2 points and the slope of the tangent at a point. Every rate of change has both an average rate of change and an instantaneous rate of change, you guys. Speed also has an average rate of change, and we call that average speed. And then there's instantaneous speed. Are you all good so far? Speed can be broadly divided into two categories. Why? Since speed is a rate of change, and there are two types of rates of change. We first have the average rate of change, which is average speed. There's the instant rate of change, called instantaneous speed. For average, we say average, and we call it average velocity. The instantaneous rate of change, or instantaneous speed, is referred to as instantaneous velocity. If there's no specific mention in the problem, it's all instantaneous speed. By the way, even if you don't explicitly state the word instant, find the velocity when t is 0 and when t is 3. All of this is just instantaneous speed, you guys. Speed is the rate of change. There are two types of rates of change. There is average rate of change and instantaneous rate of change. How do we calculate the average rate of change? Average rate of change. The average rate of change is delta divided by delta. The instantaneous rate of change is delta divided by delta, right? Rate of change of velocity. Velocity is the rate of change of position. So velocity, average velocity is the average rate of change of position, and the average rate of change of position is delta. It's divided by delta t. This is the average rate of change, right, you guys? Instantaneous velocity is the average rate of change first. And then if you apply a limit to it, that becomes the instantaneous rate of change. Guys, when we find the slope between 2 points, we find it as delta y divided by delta x. This is the slope between 2 points. If I send delta x to 0 here, this changes to the instantaneous rate of change of the slope of the tangent line at 1 point. Guys? Right. So this can be rewritten using the symbols di and dx, right? It's just the same thing, but x and y have changed to s and t. So what do we do with the average rate of change we just calculated? If we let the change in the denominator, delta t, approach 0 in delta s divided by delta t, it just becomes the instantaneous rate of change, and we write that as ds dt. Is that clear so far, you guys? Speed is a rate of change. What kind of rate of change? It's the rate of change of position. The rate of change of position with respect to whom? It's the rate of change of position with respect to t, to be precise. But can we just say it's the rate of change of position? Since it's a rate of change, there are two types: average rate of change and instantaneous rate of change. To find the instantaneous rate of change, you always have to calculate the average rate of change first, and then let the change in the denominator approach 0. So we calculate that first. The average rate of change is simply delta s divided by delta t. For example, if an object was at 3 when t was 0, and then moved to 10 when t was 2, you would find delta t and calculate delta s over 2, which gives you 7. So 7 divided by 2 is the average speed, right, you guys? Are you all good up to this point? But what we're mainly interested in calculus is the instantaneous rate of change. Guys, if we set delta t to 0 here, we can get the instantaneous rate of change at any instant. Here, the instantaneous velocity is delta s divided by delta t. The average velocity is dx divided by dt. Do you understand, guys? Even if there is no need to say average velocity, if you ask to find the velocity from t bar 0 to t bar 3, this is obviously the average velocity. Even if the term instantaneous isn't mentioned, for example, if you're asked to find the velocity at t equals 5, that's all instantaneous velocity, you guys, is that correct? We write the position function as st, and looking at this equation, you guys, the derivative of the position function with respect to t is the instantaneous speed function. From now on, we will write this as vt. Write the position function as st. The derivative of st with respect to t, which is st, is the instantaneous speed function. In short, the speed function is all about instantaneous speed, you guys. This is vt. If you differentiate the position function with respect to t, it becomes the instantaneous speed function. So this is what we all did last time, right? Let me add one more concept here. There is a concept called speed. Speed. What's the difference between speed and velocity, guys? Do you know? We didn't talk about it last time, but there's the concept of speed. What is speed? Velocity. And velocity? Hey guys, when you get in your car, there's that dashboard, right? There's a dashboard in the car, the dashboard that shows the speed. That dashboard is the speedometer. There are cars without dashboards, but what shows up in the car is not velocity. It's speed, guys. Speed is a value that only represents magnitude, regardless of direction. It only shows magnitude, right? Do I just want to find the magnitude of something? When we calculate that thing we're going to use, we use the absolute value symbol, right? Speed is the magnitude of velocity. It's the absolute value of velocity. Speed is just looking at the magnitude from velocity. This is the definition of speed. If you remove the absolute value from vt, you get speed. Is everyone okay up to this point? Hey guys, velocity has direction. How do we express that direction? If this is movement in one dimension, it tells us the direction with plus and minus, right? So velocity is a vector. Since it includes direction, velocity can express direction, but speed just turns everything into positive when it becomes plus or minus, right? So it can't express direction because it only has magnitude. We also call it a scalar. It's a scalar value. This is a scalar value and a vector value. Again, guys, when an object moves to the right, its position increases and the change in position is greater than 0. The speed calculated from the change in position is also greater than 0. Let's go back to when an object. If you move to the right, the position increases, so the change in position is greater than 0, and the speed calculated from the change in position is also greater than 0. On the other hand, if it moves to the left, its position decreases, and the change in position is less than 0, so the speed calculated from that is less than 0. So, to determine whether this object is moving to the left or to the right, we can check if the position is increasing or decreasing, or we can see if the speed is less than or greater than 0. Guys, if we're given a position function, like a position function of t, we can figure out when and where it's increasing or decreasing to know which direction it's moving. If we were given a speed graph, what would we look at? Are we looking at the sign? If the speed is positive, it means it's moving to the right, and if the speed is negative, it's moving to the left. Got it, guys? Is everyone okay up to this point? What is speed? So it's just looking at the magnitude of velocity. Just the magnitude. Whether it's moving to the left or moving in the negative direction, speed just takes the absolute value and talks about the positive value. It's simply looking at the speed of the object, not its direction. It doesn't matter if it's moving to the left or to the right. When we step on the gas really fast in reverse in our car, the speedometer just shows 20, even if we're going backward, right? Is that how it is? It gives us a value that tells us only the magnitude, regardless of direction. We call that speed in English, right? You need to be able to distinguish between these two, speedy and velocity. And let me try this. I'm going to draw a position graph. And with this position graph, let's try to figure some things out. The horizontal axis is always t. It has to be t. And this here is either s or v, right? So when you guys look at any graph, you have to check this first. Is it s or t? So I'm going to draw just one S graph. Let's draw just one shape like this. This is a graph representing the position function of an object. I'm going to ask a few questions. Go ahead and write down the answer. First, when do we change direction? Look at this position graph and think about it, guys. When do we change direction? When does it pass through the origin? What is the velocity when t is 1? What is the total distance traveled for 6 seconds? What is the distance traveled in 6 seconds? You should think about the answers to these 4 questions while looking at the graph. When do we change the direction of motion? When t is 4. Is this really mid class right now? So this object starts moving right from the beginning. So should we go to the left? Should we go to the right? To the right, yeah. Go to the right. The reason we're going to the right is that the displacement is increasing. What is the initial displacement of this object? What is Mitch's initial value? The initial displacement is asking what s is when t is 0. S is the displacement right now. So, looking at this point, since s is 3 when t is 0, we think that this object started from 3. It starts here, and the displacement increases at first. It increases all the way up to 5. So it increases to 5 when t is 1, meaning it has gone up to 5 at that point. Do you understand up to this point? Yes. From here, the displacement starts to decrease, right? What does that mean? So that means it started to turn left from here. At this point, the direction of motion changes. So when you look at the displacement graph, you can find the change in direction by looking for the maximum or minimum. When is t? When t is 1. So the position increases and then decreases, which means the direction of motion changes once. When t is below 5, it decreases and then increases, so it turns left and then right. This object changes its direction of motion twice, at t equals 1 and t equals 5. Are you okay up to this point? When does this object reach the origin? When the y-coordinate is 3. Here, if we say d is the origin, that means this is the origin. On the number line, it represents 0, right? It's not the original position. It's not the initial displacement. So it started from 3, right? So it comes like this, and that's what I was asking about. I'm asking about when s is 0, not when s is 3, and not when it's at the initial position. Do you understand what I'm saying? So, when is t? 4 days. When t is 4, it passes through the origin. It says to find the speed when t is 1. How do you find something like this? What is speed? Speed is the derivative of position. What does that mean? In this position graph, the slope of the tangent line represents the speed at that point, right? If they give us a position graph and ask for the speed, we just need to think about the slope of the tangent line. So guys, when t is 1, the slope of the tangent line is 0. So can we just say it's 0? It's asking us to find this. This is the differential value. The derivative value at 1 is 0. This means that the length of the tangent line at that moment is 0. Do you guys understand this? Think about the last question. What is this? While looking at the displacement of this object, we can think about how it moves, right? It should move like this, right? So it went to the right, then to the left, and then back to the right. The last question is to find the total distance this object has moved. Do you think you can do it? The distance this object has moved. We haven't done this, but we can think about this question for a moment. How far has this object moved? I think it's 10 at first. How far did it go from 3? So it moved 2 units to 5. How far did it go from there? Back to 0 to 0 again. Wait, it goes from 0 to here. It goes all the way to -2, right? Since it met here, it moved 7 units to the left. And from here, how much does it go again? It's 7 units. Are you going, if you add all of this up, it becomes 10. Can we just add it all up like this, guys? We figured it out by thinking about how this object moves, whether it moves to the left or to the right, and just adding everything up. Do you understand? We'll do this a little later. I thought about it in advance. You can think of the distance moved in this way. It's 10. The most important question with the location graph is the first question. Guys, this is definitely me and definitely the moment when the direction of movement changes is always included in the problem. So when we simply look at one-dimensional movement, whether we are moving to the left or to the right on a straight line, the most important moment is naturally when the direction of movement changes, right? When going from right to left or from left to right. We found the points where the position is increasing and then decreasing, or decreasing and then increasing on the position graph. It's the turning point of the position graph. So to summarize, when the direction of motion changes, if we are given a position graph, we just need to find the turning point on that position graph. Is this okay, guys? Come back here. We learned the concept of position and saw the rate of change of that position, and we named it velocity, and we said that the value obtained by looking only at the size of the velocity value is called speed. What we were curious about next is something like this. I know this object is moving fast, but I know it's fast, but it's like this again. A person is an object. If at t equals 1, it's moving at a speed of 20. And then when t becomes 10, it's moving at a speed of 50. Then we start to wonder about this. How much faster did it get? The speed? We call the speed going from 0 to 100 in 3 seconds a 0 to 100 or 0 to 100 time. So this raises a question. Some cars take 3 seconds to go from 0 to 100, while others take 5 seconds to do the same. Right? It went from 0 to 100, but what we're curious about is how quickly it got to 100. How quickly did the speed increase? You might be curious about this, right? That's what we call acceleration, guys. Similarly, when the velocity changes by 100, we need time to figure out how quickly that velocity changed. So, if we divide the change in velocity, which is delta v, by the change in time, we can find out how quickly v is changing, and we define this value as acceleration, guys. Is this correct? So, acceleration is also a rate of change, right, guys? Whose rate of change is acceleration? It's the rate of change of velocity, right? Is this okay? Acceleration is the rate of change of velocity. Guys, acceleration is the rate of change of velocity. Acceleration, the rate of change of velocity. Why is it the rate of change of velocity? Since we divided the change in velocity by delta t, so acceleration is the rate of change of velocity. Since this is also a rate of change, there are two types, right? What kind of rate of change? There's the average rate of change and the instantaneous rate of change. The average rate of change is called average acceleration, and the instantaneous rate of change is called instantaneous acceleration, right? You guys can think about that too, right? How do you calculate average acceleration, kids? It's just delta v divided by delta t. How do you calculate instantaneous acceleration? You always find the instantaneous rate of change by first calculating the average rate of change, and then you let delta t approach 0, right, guys? So, how does this equation change? It becomes dv dt. I'll skip the process and just write the result. So, acceleration also has two types of rates of change: average acceleration and instantaneous acceleration. Average acceleration is delta v divided by delta t, and instantaneous acceleration is dv divided by dt. Is this all clear, guys? So, guys, this is the process we've gone through, right? Here, we let delta t approach 0, so delta changes to d, like this. What is velocity? Answer me, guys. Velocity? What is velocity? It's the rate of change of position. Right? It's the rate of change of displacement. Rate of change of position. Velocity has two types: average rate of change and instantaneous rate of change, which are average velocity and instantaneous velocity. Both average velocity and instantaneous velocity involve dividing the change in position by delta t, and that's the same. It's like this. Average velocity is 10 divided by 2. And then for instantaneous velocity, it's like dividing by 0. How much divided by 0? It's like this, right? This is the feeling I was talking about. So again, velocity is the rate of change of position, guys. Since it's a O rate of change, it's the change in quantity divided by the change in quantity. But because it's the rate of change of position, we divide the change in position by delta t. This is average velocity. When we let delta t approach 0, it becomes instantaneous velocity. This is what we call velocity. Is this correct? What should we look at for velocity? You need to look at the sign. By looking at the sign of the velocity, you can tell whether the object is moving to the left or to the right, right? Is this okay, guys? But what else am I curious about? Velocity is the rate of change of position, but I'm also curious about the rate of change of velocity itself. Like if this object is moving fast, how much faster did it get? Or if it's slowing down, how much slower did it get? Things like that. How quickly it slowed down or how quickly it sped up, things like that. So, to find the rate of change of velocity, you naturally divide the change in velocity by delta t. To calculate the rate of change of velocity, you divide the change in velocity by delta t, and that gives you the rate of change of velocity. This is average acceleration, and just like before, if we let delta t approach 0, it becomes instantaneous acceleration. Got it? Do you guys understand this? So after looking at that, we see that velocity itself is the derivative of position. But then when we look at acceleration, guys, we see that acceleration is what we call a. It's called a. And we write the acceleration, the instantaneous acceleration function, as at. The at function is the derivative of the velocity function. But velocity was the derivative of position, right? So the acceleration function is, it's the derivative of position. This is the derivative, right? Second derivative. Acceleration is the derivative of velocity. Velocity is the derivative of position. Acceleration is the derivative of position. This is the derivative. You can even see these three relationships. If you differentiate the position function, velocity function, and acceleration function, you get it. If you differentiate, you get it. In the position function, it means the slope of the tangent line and the velocity. Why? Since the derivative of position is the velocity function, then when I give you the velocity function, what does the slope of the tangent line from the velocity function represent? It would represent acceleration, right? Are you okay? Let me draw a velocity graph. I'll also give you another problem. Guys, try to solve these two. I gave you a velocity function. In this graph, I've included the equation. You guys need to look at the velocity graph and find out when the direction of motion changes. Think about what the acceleration is when t is 2. All right, everyone, when we factor this, we get t1 and t3. So we know what these points are, right? They're 1 and 3. Not just this, but we can also find the v-intercept. When this object starts moving, does it move to the left at first, or does it move to the right? To the left. Why is it moving to the left? So, if the speed is decreasing, does that mean it's moving to the left? Oh, no. If you're driving and your speed changes from 100 km/h to 50 km/h, does that mean you're going backward? No, when we're looking at velocity, in terms of direction of motion, we're not just looking at whether it's increasing or decreasing, we're looking at whether it's positive or negative. So, the velocity is positive at first, so it's moving forward. As I move forward, my speed is decreasing. You're still moving forward. So, when you look at the velocity graph to determine the direction of motion, you need to check the sign. So it goes to the right until t is 1, then it goes to the left from 1 to 3, and after 3, it goes back to the right. Is everyone okay up to this point? Yes. So the moments when the direction of motion changes are when the sign of the velocity changes, which happens at t equals 1 and t equals 3, guys. Is this correct? The points where the direction of motion changes are where the sign changes on the velocity graph. The points where the increase and decrease change on the position graph. You need to distinguish between these two. Well, okay, the most important question is this, guys. This one, the first one. If you don't know this, just go to this section. You really can't not know this. It's the most important thing, the most basic thing. Is this okay, guys? How do you find the acceleration when t is 2